Hey guys, it's Mr. Lowry here. This assignment is the in-class assignment for 11/11 for Cohort A, that's Wednesday, or 11/12, November 12th, which will be Thursday if you're in Cohort B. We worked through this in class in groups, but I wanted to give you some experience with these types of problems because there could potentially be one on a quiz or test at some point, and I want you to know how to do it. This worksheet is all about domain and range from a real-world context. So earlier this week we did an in-class assignment as well where we talked about the domain and range of a real-world scenario when we were ordering shirts, basically. And we talked about domain and range. This is a little bit of an extension of that type of idea. So what we're going to do is we're going to read through these scenarios, and then we're going to try to answer questions about domain and range based on the context that we're in. Okay. The first one here says Joe had a summer job that pays $7 an hour, and he worked between 15 and 35 hours every week. His weekly salary can be modeled by the equation S equals 7H, where S is his weekly salary and H is the number of hours he worked in a week. There's a lot of information in there that we need to unpack. Let's go ahead and start by talking about our variables. The first question here talks about the independent variable and what the independent variable is. So remember that independent variable is talking about the input, or that, like, traditionally independent is X. In this case it won't be X, it'll be a different letter, but it's usually the X variable. Okay, so we're talking about input. There's two quantities here that we're talking about, right? We got hours that he worked in a week, and we also have weekly salary. Okay, they're both going to change depending on the week. One is going to be based on the other one. One's going to depend on the other. So what we have to think is which depends on which. In this case, weekly salary is going to depend on the hours that he worked. So weekly salary depends on, is dependent, this guy, which is independent. So independent is hours. Hours worked. And the variable that we have for that is H. All right. That means that the dependent variable is weekly salary, but it doesn't ask us for that. That's part of the, not part of the question. The other thing we might want to do is take this equation here and write it in function notation. So since weekly salary depends on hours worked, that means salary is a function of hours. And so this is how this equation would look in function notation. It's the same kind of thing, only I have this H next to the S to say that this will depend on this. Salary will depend on hours. Okay. Now this asks for domain and range, and one thing that we need to know about domain and range is whether it represents inputs or outputs. Okay, so the domain is all the possible input values, and the range is all the possible output values. Again, this is going to go back to independent and dependent. So input has to do with independent, range has to do with output. So for the domain, we're talking about hours, and for the range, we're talking about salary. But what we want to know is, what are the limitations? Okay, we have to think about the context of the problem with the information that they're giving us. Okay, so here's some questions that you should ask yourself. Anytime you're trying to find domain and range from a real-world scenario, here's some things to ask. Okay, first thing you might want to know is what values don't make sense. Okay, in this case, we're talking about money and we're talking about time. So it probably doesn't make sense to talk about negative hours. It probably doesn't make sense to talk about negative money in this case. So negatives don't really make sense here. The other thing we might want to ask ourselves is discrete or continuous. Okay, what that means is, are there spaces or gaps in between the numbers or not? Okay, in this situation we're talking about time. So we're talking about, do decimals, do fractions, do those make sense in the context of this problem? Does it make sense to work 4.5 hours? Does it make sense to work 9.6 hours? Does it make sense to work 34.99 hours? And in this case, I would say, yeah, if you're working for 5.5 hours, you want to get paid for 5.5 hours. So having a number between 5 and 6 hours makes sense. So in this case, I would say this is continuous. There are not spaces in between. All the numbers in between 5 and 6 or 6 and 7, those all count. Okay, the other thing we want to look for is anything that has a minimum or maximum value. Now sometimes they'll just tell you, sometimes you have to infer from the context if there's a minimum or maximum. Now in this case, they say he wants to work between, or he worked between 15 and 35 hours. So this is our min and this is our max, right? So for my domain here, I'm thinking, what are all the possible numbers of hours I can work? Okay, well the minimum is 15, okay, and the maximum is 35, and anything else in between counts. I could do 15.1, 17.3 hours, 34.9, all of those work. So I'm going to use interval notation, okay? If your domain is continuous and your range is continuous, use an interval. If your domain or range are discrete, you're going to use set notation. Okay, so continuous, we're going to use intervals. That means all the numbers in between count. Discrete, we're going to use a list or a set, which is going to have those curly brackets on the outside. This question will tell us what our domain and range will look like in symbols. Okay. For the range, we're looking for all the possible salaries that you could get. Well, the first thing we need to know is what's the lowest possible salary? What's the salary for 15 hours? So what we want to find is we want to find S of 15. Okay, S of 15 is going to be 7 times 15. Grab my calculator really quick here and see what that comes out to. You can do the same on your own. Okay, so I get 105. So 105 is the lowest possible amount of money I can make. That's the amount of money I make if I work 15 hours. Okay, now I want also the maximum amount of money. The maximum amount of money is what I'm going to make if I work 35 hours. So I'm going to do 35 times 7, and that's 245. Okay, so my range is anywhere between 105 and 245. Now, again, this interval means that this is a continuous range. So if you think about it, does it make sense to get decimals or in-betweens? Does it make sense to have something in between 105 and 106? Well, if you had like 105.7, that'd be $105.70, and that's okay. So the in-betweens make sense. We're not really going to have spaces in between values here. They're all going to be next to each other. All right, number 3. What does each value in the ordered pair mean in context of the problem? Okay, well, this is your input. This is 20 hours, and this would be $140 in salary. So you get paid $140 for 20 hours of work. Something like that. You don't have to use those exact words, but that's kind of how it goes. All right, so these questions are going to be really important for you. What values don't make sense? All right, throw them out. Those won't be in your domain or range. Discrete or continuous? Do I have holes? Do I have gaps? Do I care about the in-betweens or no? What's the minimum? What's the maximum? Okay, and remember, discrete or continuous will tell you whether you're going to use an interval or whether you're going to use a list. All right, let's look at this next guy here. All right, Hector's Service Club is raising money by wrapping presents in the mall. The function f of x equals 3x describes the amount of money in dollars the club will earn for wrapping x presents. They only have enough wrapping paper to wrap 1,000 presents. Okay, so there's two things that are changing here, right? There's an amount of money in dollars, and there's the amount of presents. Both are going to change. Both are going to vary. What depends on what? Okay, in this case, the amount of money that you make is going to depend on the amount of presents you wrap. So money depends on X, presents. So X is the input, number of presents is the input, which makes it the independent variable. Okay, now amount of money is going to depend on the amount of presents wrapped. So this is dependent on this, or amount of money is a function of presents wrapped. Okay, so dependent variable is the amount of money that we make, or amount of money earned. That is the word that they use, and that's they use F for that here. Okay, so domain and range, we're going to ask ourselves these same questions. Okay, first of all, what values don't make sense? Does it make sense for him to wrap negative presents? Not really. Does it make sense for him to wrap half of a present or 3/4 of a present? Doesn't make sense in this context, right? So the in-betweens don't really make sense. That means that this is discrete, right? You're going to have spaces in between the input values. You can't have in between 1 and 2 presents. You can't have in between 2 and 3 presents. You can only have 1 or 2 or 3. Okay, another thing to think about is, does 0 make sense? In this case, if you had f of 0, that'd be 3 times 0. And so you would say, all right, well, if you wrap 0 presents, you're going to get 3 times 0, or $0. And so you may or may not want to include that in your domain. It kind of depends on what makes sense. Now, if your service club is raising money, then hopefully you're going to get some presents to wrap, but it's possible that nobody comes in and you get 0 presents. So sometimes, depending on the context, you might include 0 or you might not. In this case, I think there's an argument either way to say, yeah, I should include 0 or yeah, I shouldn't. And I think for me, I'm just going to go ahead and include 0 for that case where we might not get any presents to wrap. So I know this domain is discrete. I know that it's going to have spaces or gaps. So instead of using an interval like this, I'm going to do a list. Okay, so I'm going to use these curly brackets, and I'm just going to start with 0. Okay, 0 is the lowest amount of presents I can wrap. I can't wrap half a present. I can't wrap 3/4 of a present. The next present I can wrap is 1. Okay, I can't wrap, 1.5 presents, so the next one is 2 and 3 and so on. Right? Now, if we make this list, we're going to go 0, 1, 2, 3, 4. We're going to have to go all the way up to 1,000 because that's our max. So what I would do in this case, if I'm making a list and I write some numbers and I need to, a break here, I would do ... and then at the very end put the max. What this represents is a list of numbers from 0 to 1,000 that only includes the whole numbers. So this is a discrete domain. This is a list. This will save you from writing them all out. But you should, in a list, you should list out the first few numbers so you can see the pattern here, right? 0, 1, 2, 3. You want to start seeing that pattern. Since we don't have enough wrapping paper to wrap more than 1,000, 1,000 is going to be our max. So that's our last question, right? Is there a minimum or maximum? Well, 0 is probably the least number of presents I can wrap, and 1,000 is the most. So this is how I would write in set notation, or excuse me, set notation. Okay, now for the range, again, I want to think about these same types of questions. Am I going to have in between money? What's the lowest amount of money I can make? What's the highest amount of money? All right, so let's think about if I were to wrap 0 presents, I would get $0, and that's the least amount of money I can earn. Now I can't wrap half a present, so the next amount of presents I could wrap is 1. So over here, how much money am I going to get for wrapping 1 present? Well, f of 1 is 3 times 1, which is 3. So this function tells me that I'm getting basically $3 per present. Right? F of 2 is going to be 3 times 2, which is 6. So I can make $3, I can make $6. Notice there's no way for me to earn $2. There's no way for me to earn $1. I can do 0 or 3, and the in-betweens, there's like a gap in between here. Can't earn $1, I can't earn $1.50, I can't earn $2. It just goes 0, 3, and then 6. Okay, after that I could make $9 if I wrapped 3 presents. and so on. And you can see the pattern. It's not every number, it's every 3 numbers, basically. Okay, we also need to figure out how much money we can make at the maximum. So if I wrap 1,000 presents and I get $3 for each one, I want 3 times 1,000. F of 1,000 would be 3 times 1,000, or $3,000. So that is my range. It's all the possible outputs, or in this case, all the possible amounts of money I can earn. There's no way for me to earn $9.1. There's no way for me to earn $3,010. There's no way for me to earn -$1. It's either 0, 3, 6, 9, or some multiple of 3 up until 3,000. So compare and contrast. Continuous, domain, and range. We're using interval notation. Discrete, domain, and range. We're using set notation. How do we know? We have to ask ourselves questions from the context of the problem, right? These are the 3 questions I would ask. Okay, let's look at the backside here. We won't go through the whole thing, but we will kind of break it down a little bit. Okay, so we want the surface area of a cube can be found using the following formula. Okay, now real quick, this is 6 times s squared. In function notation, that'd be a of s equals 6s squared. If I want to find, let's say, a of 5, that would be the surface area for a cube that has a length of 5 for one of the edges. Okay, that would give me 6 times 5 squared. Now, in class, a lot of people had a hard time with this because of order of operations. Don't do 6 times 5 first. You got to do 5 squared first. So 5 squared would be 25. Multiply that by 6. This is going to give you 150. So just kind of unwrapping that function. So this is the function where A represents surface area of a cube, and S represents the length of one edge. Your geometry teacher wants you to draw a cube that has a length of at least 5 inches. All right, so a cube is going to kind of look like this, right? And one of the sides of these guys is length 5, or at least 5, right? So if that's 5, then this is 5, and if that's 5, then this is 5. And the surface area would be like the outside, all the outside surfaces added together. If you were to paint this, the outside of this cube, it's kind of like how much paint would you need to cover this cube. Okay, so this function here will give you the surface area for a given side length. All right, now what's going to happen here is that A, the surface area, is going to depend on S, the side length. So area depends on side length. Area is a function of side length. Okay, that means area is the dependent variable and side length is the independent variable. So I'll let you jot that down. All right, questions to ask ourselves. 1, what numbers don't make sense? Okay, domain is all the inputs. In this case, that's going to be all the possible side lengths that we can draw for this cube. Range is going to be outputs. That's all the possible surface areas we can have. Okay, does it make sense to have a negative side length? Not really. Does it make sense to have a side length of 0? No, because we need at least 5 inches, right? Does it make sense to have a side length that's like 5.5? Yeah, we could do 5.5 inches. That's fine. There's nothing wrong with that. That means that this situation is going to be continuous because we're not going to have gaps. We can have 5, we can have 5.1, we can have 6.7. The in-between numbers are important. We don't have any gaps. So I would make a note to myself that this is going to be continuous, which means I'm going to use an interval. Okay. Also, we want to know about max and min, right? Well, the minimum is 5. So we have that. The maximum, it doesn't say, but you have to think about this in context, right? We're drawing a picture of a cube. On what? Well, we're not sure, but let's assume a piece of paper. Let's just make some assumptions here. If I draw a cube on a piece of paper like this piece of paper is 8.5 by 11 inches, okay? And I'm going to have to fit that cube on there. So, you know, I definitely can't be longer than 8 inches or 8.5 inches one way. Otherwise, we'll come off the paper. So even though it doesn't say what the max is, we kind of know from inference here, if we're talking about a piece of paper, that there is a limit to how big our square can be. Now you might assume that you're potentially using a bigger piece of paper, and if that's the assumption you make, that's okay. We'll just assume a small piece of paper. Also, we're going to have some extra room here. So if this is, let's say, 8.5 and this is 11, right? If I draw my cube, I can't just make it all the way to the edge of the paper because I have to kind of have some space to do the three-dimensional stuff. So I'm going to say that my biggest possible cube that I'm going to draw is around 8 inches. Now again, that's just an estimate and that's using some assumptions, but in the context of this problem, I think that makes sense. So the smallest cube I'm going to have is 5, and then the biggest possible cube I'm going to have is going to be 8. We want to include everything in between, so 5.1 works and 7.9 works, right, and 6.05, all those things. So the interval notation means 5 to 8 and everything in between. Okay. The range for this guy kind of depends on the domain, right? We know that the area is a function of side length, or area is dependent on side length, and so the range is going to depend on the domain. The lowest possible side length I have is 5. Well, what's the surface area for a side length of 5? We actually already figured that out. It's 150. All right. Well, what is the maximum amount of surface area? Well, the biggest cube I'm going to draw has a side length of 8. So what we want to try to find is a of 8, right? That would be 6 times 8 squared. Okay, do the squared first. 8 squared is 64, and then multiply that by 64, or excuse me, multiply that by 6, and you get 384. So the biggest possible surface area is going to correspond to the largest possible side length in this case. All right, so that will help you get started there. That's not all of it, but that'll help you get started. Okay. The last one I want to show you, it has a graph with it as well. So you're going to have to figure out independent and dependent. The nice thing is the graph kind of tells you this is the x-axis usually, and this is the y-axis, and x-axis is the independent axis of the independent variable. Okay, so when you give in a graph, the horizontal one's always independent, so that should help. That means height depends on time. We're talking about a ball that's thrown in the air. The height of the ball depends on how long it's been in the air. Okay. One thing to keep in mind here as you're doing this is that your maximum does not correspond, your maximum height does not correspond to your maximum time. In this case, and in the other scenarios here, we knew that the maximum of the domain corresponded to the maximum of the range. But that's not always true, right? If you look at this thing, the maximum height of the ball does not happen at the maximum time. The lowest time here is 0. The highest time here is about 4.5. But the highest height does not happen at the highest time because of gravity. This ball is going to go up, it's going to reach its highest point here, and it's going to come down. Now think about time and height for a second. Okay, what's the lowest height you're going to have? 0. What's the highest height you're going to have? It's going to be this guy. Okay, what's the lowest time you're going to have? 0. What's the highest time you're going to have? 4.5. Do the in-betweens make sense? Does it make sense to have 3.5 seconds? Yeah. Does it make sense to have 70.1 feet? Yeah. So this is going to be continuous. So you're going to want to use an interval here. So a little note, continuous, interval, use an interval. And you're going to use your lowest time and your highest time, your lowest height and your highest height. And you're going to use interval notation similar to this. Okay, so that should help you get started. You should finish that up and make sure you understand those concepts because, again, there could potentially be one of those on a test or quiz coming up. And that's what we did in class. We're going to use these ideas of domain and range on a homework assignment, and that'll be in a different video. So this is the in-class, again, for Wednesday, November 11th for Cohort A, and Thursday, November 12th for Cohort B. And homework's coming up in the next video.